So I'll wear a couple hats here. I'll wear my FRI FSCP hat and also my West Fraser hat. A little bit of the history of this project, actually a history of the program first. So it was learned probably 20 years ago that there were a lot of older stream crossings on the roads in the foothills that weren't up to current standards and expectations. And those were expectations about whether fish could get through the crossing, whether there was enough capacity to take floods, whether there was dirt going into the creek, whether it was safe, a lot of different factors. And so there was efforts to start understanding what the magnitude of the problem was and what could be done about it. So FRI early on through the Fish and Watershed program had an initiative to look at culverts and look at whether or not they were really blocking fish, and look at which fish were above and which fish were below and things like that. That eventually led to the Foothills Stream Crossing Partnership, is what it's called now. And that was one of the FRI associations, and it consists of a number of forest and energy companies that all wanted to get together to do two things really. One, to do an inspection of their crossings to see which ones needed repair, and then two, to work with the government to come up with priorities for which ones should be repaired first and get on with it. And this is just an example of one of those crossings. And this actually is an interesting story behind this one. If you remember the CN rail spill on Wabamun Lake a number of years ago, well, CN, as part of the settlement of that accident, had to provide funding for environmental projects. And Nao Burrill, the project manager for the FSCP, snared some of that money to help replace this crossing. So it actually got replaced a little earlier than it might have been according to the schedule of the industry partners. So CN put up, I can't remember the exact amount, but it was a little over $100,000. And West Fraser supplied the additional funding. And NAO coordinated it all. We brought in an engineer from BC, and this is a somewhat unique structure. It's a first for Alberta as far as we know. It's called Geotextile reinforced soil. And what used to be here was a 5-foot round culvert. It was inadequate to pass the entire flow of Hardisty Creek, and it also, because it acted like a garden hose and increased the velocity of the water within the culvert, scoured out a big pool at the bottom of the culvert, and that was creating a hang, and it was a fish barrier, or a partial fish barrier. So it was on the list to be replaced, and so the funding source came together. The engineering and the new method came together, and several years ago we replaced that culvert. And it's interesting because you can see the arch of the GRS is far wider than a traditional culvert, but it's just a half culvert. It's a natural stream bed going through there. And the neat thing about GRS is it's actually these layers of geotextile reinforced with metal mesh that holds the thing up and supports the road. It's not the culvert. So the traditional thing is the culvert had to be strong enough to hold the road up, but this actually is the structure. It's just like the arch over a stone building in a church or something like that. That holds up. You could actually take that metal cylinder out of there now and it wouldn't make a darn bit of difference. Everything would be good. And this technology is not new. It was actually used in the Great Wall of China a couple thousand years ago. One of the advantages, of course, is you do have a natural stream bottom, so it's not a problem at all for fish to get through there. But some other advantages are it's easily going to be able to take the peak flow. The calculated peak flow of a 1 in 100 year flood would only have water inside that structure about 1 meter deep. The other big advantage is we were able to put a double wide crossing here because, as you can see, we're at the base of a hill and we're hauling big trucks down there. It's not safe to have a single wide crossing on a double wide road. People tend to have accidents on those things. So we needed a double wide crossing. To put in another conventional culvert adequate to take the flow would have been horrendously expensive. Plus we would have had to embed it, which was a lot of work. And to put in this GRS arch was considerably less expensive than a 2-lane bridge would have been. So it worked out good on the cost side. Excellent for safety, excellent for the environment, and just a general good thing. So just a couple words about how it was done. Nowadays, we couldn't just rip the old culvert out and slap the new one in. So we actually had to build a diversion channel. It goes behind you. Actually, this is where it used to start right here, the pile of rocks behind Darren there. That's called a French drain. So it's actually a diversion culvert that's underneath the thing, and the ditch water drains into that and drains down and through there. So the entire creek was diverted through that diversion tunnel, and the old culvert was removed and the new installation was put in the dry. And then water was allowed to come through there very carefully, and the dirty water was pumped off into the bush. So the whole thing was done without any dirty water getting into the creek. It cost about $250,000 in total. So the FSCP has spent a lot of money figuring out problems, and a lot of money by member companies fixing problems. I don't have a number, but it's in the tens of millions so far, and growing every year. So one other thing, you'll notice here these little sticks of branches. Dale brought a high school class out here, and they planted willows. The idea to try and reestablish some streetside vegetation. Some of the willows are living. I guess Dale would count that as success. They'll probably fill in over time, but a lot of them didn't make it, of course, because they're just sticks stuck in the ground. Gregg River here is quite a mobile river. It changes its channel when we get big floods. And last summer we had a big flood, and the river used to just kind of come around and cut by those willows there, and it eroded quite a ways over that way and made a big S-curve. And instead of coming directly under the bridge like it used to, it was heading right into the road abutment right here. And as a matter of fact, we had water starting to collapse the road abutment here, and we had to throw this rock in here while the flood was on, just to save the road. And then afterwards, when the water went back down, we had to decide how to protect the site here. And our engineer friend from BC, the same guy that developed that GRS structure idea, he says, well, why don't you build an engineered log jam? And I said, well, what's that? And he says, well, here, I'll show you. So that's what this is. I don't know if you noticed, but just back over there, there's a little clear cut. We went in there with a big excavator and ripped the trees out by their roots, hauled them down there, and got a couple of guys with fire hoses to hose off all of the dirt. And then we came and very carefully constructed this log jam with all of those trees. And it's actually woven together so it has strength. And you see chains and big rocks. Those big rocks have holes drilled in them, and there's epoxied pins in them and chains going between the rocks. So the whole thing's weighted down by these huge big boulders. And we had to get DFO and Alberta government permission to do this, of course, and we actually talked DFO into letting us carefully place those logs right into the channel during the fall, right about now when the whitefish run was starting to go on. And I was here when they placed the first root rod into the channel. I was just kind of standing there watching. Within 10 minutes there was a whitefish underneath that root rod. So it's also a habitat improvement project in a way, because it's created actual fish habitat. And we had another freshet this year, and you can see the river brings down more material. So the idea is that over time the river itself will replenish the log jam, and it'll have the permanent function of protecting the road here. And if the flood comes again, it'll bounce off that and might actually go back into its old channel, so it should protect the road. And compared to bringing in more riprap and sort of doing the armor approach, it was a lot less expensive. And of course, most people driving along here have no idea what went on, because it just looks like a log jam.